some important physical properties of halogen derivatives. Physical properties. First important physical property, that is the nature of CX bond. That is a carbon halogen bond. This bond is a covalent bond. This bond is a form by sharing of electron between carbon and halogen atom. Here X stands for halogen atoms. That is a chlorine, fluorine, bromine or iodine. आता आपल्याला एक्सप्लेन करायचे नेचर ऑफ दिस बॉन्ड. या बॉन्ड नेमका कसा आहे ते आपल्याला एक्सप्लेन करायचे. This covalent bond is a present between carbon atom and halogen atoms like chlorine, fluorine, bromine and iodine. All these elements are elements from group number 17. Elements from group number 17 are called halogens. आपण यांना halogens म्हणतो. Halogens. All these halogen atoms are more electronegative. Electronegativity is nothing but tendency of an atom of an element to attract electron towards itself is known as the electronegativity. Periodic table मध्ये जेवढे elements आहेत ना त्यांची एक tendency आहे to attract electron towards itself. Electron attract करतात, bonding electrons स्वतःकडे attract करतात. This tendency is known as the electronegativity. And electronegativity of element from group number 17, that is halogen, is higher as compared to rest of element. Therefore, chlorine, fluorine, bromine or iodine, that is an X group, attracts bonding electron towards itself. And when electrons are shifted from carbon to halogen, this halogen atom becomes slightly negatively charged. When electrons are shifted from carbon to halogen, therefore carbon atom becomes slightly positively charged. There are two poles are formed, positively charged pole and negatively charged pole. Therefore, this bond between carbon and halogen, that is carbon and fluorine, carbon and fluorine, carbon and bromine, carbon and iodine, is a polar covalent bond. Is a polar covalent bond. And strength of this polar covalent bond depends upon atomic size and molecular mass. As atomic size and molecular mass or atomic number of halogen atom goes on increasing, strength of this bond goes on decreasing. Therefore, in this hydrogen halide, that is a carbon, fluorine, carbon, fluorine, carbon, bromine, and carbon, iodine. Strength of a bond goes on decreasing. That is, the bond between carbon and fluorine is strong as compared to bond between carbon and fluorine, carbon and bromine, carbon and iodine. The strength of a bond depends upon atomic number and also atomic size. Atomic size of fluorine is a very small. Atomic size of fluorine is a somewhat large as compared to fluorine. Atomic size of bromine and atomic size of iodine. As atomic sizes, atomic number also goes on increasing from fluorine to iodine. For fluorines are atomic number 99, fluorines are 79, bromine and iodine atomic number increases. As atomic number goes on increasing, atomic size also goes on increasing. And as atomic size goes on increasing, bond length also goes on increasing. If a bond length short and if a bond length increases, and as the bond length goes on increasing, strength of bond goes on decreasing. Therefore, bond between carbon and iodine is a very weak as compared to bond between carbon and bromine, carbon, fluorine, carbon and fluorine. Nature of bond between carbon and halogen atom. Bond कसा है? Actually covalent, but polar in nature due to electronegativity. हे सर्व atom कसे आहेत? Electronegative आहे. Electron attract करतात. म्हणून हा बॉन्ड कसा आहे? पोलर आणि कोव्हॅलेंट. नंतर कार्बन क्लोरीन कार्बन क्लोरीन कार्बन क्लोरीन कार्बन आयोडीन atomic नंबर इंक्रीज होत जातो आणि बॉन्ड लेंथ इंक्रीज होत जाते. इथे बॉन्ड लेंथ थोडी शॉर्ट आहे, इथे जास्त आहे, इथे जास्त आहे आणि इथे जास्त आहे. जेवढी बॉन्ड लेंथ जास्त असते तेवढा तो बॉन्ड कसा असतो, वीक असतो. आणि जेवढी बॉन्ड लेंथ शॉर्ट असते तो बॉन्ड असतो स्ट्रॉंग बॉन्ड. नेचर ऑफ बॉन्ड हा पोलर कोव्हॅलेंट बॉन्ड आहे आणि याची स्ट्रेंथ काय होत जाते, डिक्रीज होत जाते. पण हा बॉन्ड स्ट्रॉंग आहे, हा थोडा वीक आहे, हा अजून थोडा वीक आहे आणि हा त्याच्यापेक्षा थोडा वीक आहे. हा झाला पहिला पॉइंट. समजलं का? नेचर ऑफ कार्बन हॅलोजन बॉन्ड. कोणीतरी पटकन रिप्लाय देत सांगा का? हॅलो, रिप्लाय द्या मला. हा पॉइंट समजलं का? नेचर ऑफ बॉन्ड.
Yes, sir.
सेकंड पॉइंट, second physical property, there is a boiling point. Boiling points of halogen derivatives. Again, this boiling point of halogen derivative depends on factor affecting the boiling point. Boiling points of halogen derivatives are higher than that of corresponding alkane. जे alkanes आहेत ना, इथे हे जे कंपाउंड आहे हॅलोजन डेरिव्हेटिव्ह याचे बॉइलिंग पॉइंट हायर आहे. ते का हायर आहे ते आपल्याला एक्सप्लेन करायचं. therefore factor affecting the boiling point. Number 1, boiling point depends upon atomic size of H group, that is the halo group. Atomic size and atomic number, that is a molecular mass. As atomic size and atomic number of halogen atom goes on increasing, boiling point also goes on increasing. Atomic number increase झाला की boiling point हा increase होतो का? For example, consider. For example, first element, that is a first compound CH3F, CH3Cl, CH3Br and CH3R. Boiling point of this first compound is a 194.6 Kelvin. CH3Cl 248.8, that of CH3Br 276.6 and 5.4 Kelvin. From this first compound to last compound, boiling point goes on increasing. Boiling point depends upon atomic size. Fluorine atomic size smaller, atomic mass सुद्धा कमी आहे. Therefore, molar mass of this first compound is a small. Therefore, boiling point is a low. The boiling point of CH3Cl is a higher than that of CH3F. Why? The atomic size of fluorine is a large. Atomic number is also higher. Therefore, molar mass is a more as compared to CH3F. In this way, from this compound, that is from left to right. Left to right, atomic number goes on increasing. Therefore, molecular mass also goes on increasing. Hence, boiling point also goes on increasing. First point, first factor which affects the boiling point. Boiling point कशावरती डिपेंड असतो? हा जो हॅलो ग्रुप आहे त्याची atomic size किती आहे? जेवढी atomic size छोटी तेवढा boiling point कमी आहे. Atomic size म्हणजे molecular mass वाढला की boiling point increase होतो. Second factor which affects the boiling point, there is a number of carbon atoms. Second factor which affects the boiling point, there is a number of carbon atoms. As number of carbon atoms goes on increasing, boiling point also goes on increasing. For example, CH3Cl, CH3CH2Cl, CH3, CH2, CH2, and Cl. First compound is a methyl chloride, contains only one carbon. Second compound contains two carbon and chlorine. Third compound contains three carbon and chlorine atom. From top to bottom, number of carbon atom goes on increasing. Therefore, boiling point also goes on increasing. Boiling point of first compound is a 248.8. And that of CS3, second compound is a 285.5, and third compound is a 320.0 Kelvin. A carbon atom increase झाले की boiling point सुद्धा increase होतो. ते मी लिहिलेले आहे from top to bottom as number of carbon atom goes on increasing, boiling point also goes on increasing. And third factor which affect the boiling point. First factor क्या है? Atomic size, atomic number and molar mass. Atomic size increase झाले, molar mass increase होता, molar mass increase झाले की boiling point increase होतो. इथे explain केलं आहे. Second point, second factor is the carbon atom. As number of carbon atom goes on increasing, boiling point also goes on increasing. इथे explain केलं फक्त एक example. तिन्ही compound मध्ये halo group mix आहे, chlorine, chlorine, chlorine. But number of carbon atoms are different, 1, 2, and 3. Therefore, boiling point goes on increasing. And third factor, which affect the boiling point, that is a isomeric compound, that is a carbon skeleton. Carbon skeleton. As the number of branches goes on increasing, boiling point goes on decreasing. For example, CH3, CH2, 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 and Br. Second compound, CH3, CH, Br, CH2, and CH3. And third compound, CH3, 3 times, and Br. All these three compounds contain same number of carbon atoms, 1, 2, 3, 4 bromine, 1, 2, 3, 4 bromine, 1, 2, 3, 4 bromine. Number of carbon atoms same. Halo groups the same, but boiling points are different. That depends upon arrangement of carbon atom. There is a branching carbon atom goes on increasing from top to bottom. पहिल्या compound मध्ये सर्व carbon atom कसे present in straight chain. In second, the bromine is attached to second carbon atom, therefore one branch is present. There are two branches, side chains are present. Therefore, boiling point goes on decreasing. For example, boiling point of first compound is 375 degree Kelvin. Second compound 364 and 346 Kelvin. Second physical property, boiling point. Second physical property समजले का? मला रिप्लाय देत चला रिपोर्ट कर.
Yes, sir.
Okay. 15 point समजला. Boiling point depends upon atomic size of halo group, atomic number of halo group, and molecular mass of compound. Second, number of carbon atom. Carbon atom increase झाले की boiling point increase होतो. आणि branch chain increase झाले की boiling point decrease होतो. Then last part, physical property. Third physical property, that is a solubility of halogen derivatives. Solubility. Alkyl halides, that is a halogen derivatives of alkane, in which halo group is attached to open cell carbon atom, and haloarenes, in which halo group is directly attached to benzene ring. Halogen derivatives of alkanes, that is a haloalkanes, and such type of compounds are called haloarenes. In these two compounds, this bond between carbon and halo group is not perfectly ionic. It is not a totally polar. It is a partially polar, not totally ionic bond. Here partial negative charge is present, partial positive charge. Partial negative charge, partial positive charge. Therefore, these two type of compounds are insoluble in water. Insoluble in water. Water मध्ये insoluble. Water is highly polar. Water हा highly polar आहे. आणि हा जो आहे ते दोन टाइपचे कंपाउंड आहेत हायली पोलर नाही. Therefore, these two type of compounds are insoluble in water, but soluble in some important organic solvent. काही organic solvent आहे त्यामध्ये ते soluble आहे. Third physical property, that is a solubility. The next point, some important chemical properties. Chemical properties of halogen derivatives. Some important chemical properties, that is the chemical reactions of halogen derivatives of alkylates, alkyl halide and haloarenes. First important chemical property, that is a त्याच्या अगोदर एक पॉइंट आहे तो आपण नंतर एक्सप्लेन करणार आहोत. आवाज येतो ना? First important chemical property, laboratory test. Laboratory test. In this laboratory test, when alkyl halides are treated with reagent like aqueous solution of potassium hydroxide or sodium hydroxide, a substitution type reaction takes place. This potassium hydroxide contains K plus and OH minus ion. Therefore, in this reaction, OH group get attached to R group, OH group to form alcohol, and here K plus and X minus ion. X minus ion from alkyl halide. And when such type of when this obtained compound product are treated with silver nitrate, ROH plus K plus X minus treated with silver nitrate AgNO2 NO3. Then this halide ion and silver forms insoluble compound, that is a AgX alcohol ROH plus potassium and nitrate forms KNO3. Then insoluble silver halides are formed. This test is known as a laboratory test. Laboratory test मध्ये जो alkyl halide त्याची reaction potassium halide बरोबर, that is a OH minus ion बरोबर complete करायचे to form halide ion, and then this halide ion combines with silver to form insoluble compound, that is a silver halide. The next important chemical property, important one, second chemical property is a nucleophilic substitution reactions. Nucleophilic substitution reaction. Therefore, first tell me, what are nucleophiles? दोन टाइपचे reagents आहेत. 11th मध्ये आपण पाहिले पहा. Electrophiles and nucleophiles. Nucleophiles are nucleophilic reagent. Nucleo means nucleus, that is a positive charge, and philic, that is having attraction. म्हणजे ज्या reagentला ज्या species ला कशाबद्दल attraction असतात, nucleus, that is a positive charge, positively charged ion, त्याला आपण nucleophiles म्हणतो. Therefore, nucleophiles are Therefore, nucleophiles are electron-rich species. In this nucleophilic reagent, halo group from alkyl halide is always negatively charged. There is a Cl minus, Br minus, I minus are examples of nucleophile. And in this reaction, halo group is replaced by such type of group. There is a OH group, negatively charged OH group, Cl group, Cl group, NH2 group. Hence, reaction is known as a nucleophilic substitution reaction. या रिएक्शन मध्ये काय करायचं इथे जो हॅलो ग्रुप आहे तो काढून टाकायचा आणि त्याला दुसरे न्यूक्लियोफाइल जॉइन करायचे. Therefore, reaction is known as a nucleophilic substitution reaction. आता हे जे nucleophilic substitution reactions आहेत त्यांचे एक्झाम्पल्स आपल्याला काही पाहिजे. First nucleophilic substitution reaction, number 1. First nucleophilic substitution reaction, that is a formation of alcohols. Formation of alcohols. Their final products are ROH. In this reaction, when alkyl halides will be presented by general formula RS. When R stands for alkyl group. And H stands for halogen, that is a halide. When treated with KOH solution, aqueous solution. Aqueous solution, that is a solution is prepared in water. Just आपण water मध्ये solution तयार करतो त्यावेळेस aqueous solution म्हणायचं. In this potassium hydroxide, potassium is positively charged, OH group is negatively charged. In this reaction, this halo group and potassium forms potassium halide. And OH group get attached to R group. ROH is general formula for alcohol plus KX, that is the potassium halides are byproducts. This is general reaction. This general reaction that is. अगर actual example explain करें. For example, number 1, when CS3 CH2Br is a treated with aqueous solution of KOH. Bromine and potassium forms potassium bromide, and OH group get attached to the CH2 group to form CS3 CH2OH plus KBr. Name of this alcohol CS3 CH2 group is known as a ethyl group. OH group is present, therefore followed by word alcohol. Ethyl alcohol. One more example. CS3 CH2 Cl CS3 plus KOH aqueous. It gives chlorine and potassium forms potassium chloride and OH group to this carbon to form CS3 CHOH CS3 plus KCl. Name of this alcohol CS3 CH group is known as isopropyl group and OH group therefore alcohol. In this way, here halo group. This halo group is negatively charged and replaced by OH group negatively charged. Halo groups are examples of nucleophiles and OH group is also nucleophile. Here one nucleophile is replaced by another nucleophile. Therefore, type of reaction is nucleophilic substitution reaction. And in this reaction, final products are only alcohols. अब this simple है था. Halo group काढून टाकायचा. Halo group काढून टाकायचा आणि ज्या ठिकाणी halo group होता तिथे OH group फक्त जॉइन करायचा. समजले का रिएक्शन? फर्स्ट सब्स्टिट्यूशन रिएक्शन समझ गए?
Yes, sir.
Okay. Second substitution reaction. Second substitution reaction. That is a formation of ethers. Formation of ethers. And ethers are organic compound containing carbon, oxygen, carbon linkage. When organic compound contains carbon, oxygen, carbon linkage, then compounds are called ethers. केतन कौन है? माइक म्यूट कर.
सर आवाज ब्रेक होतोय.
केतन कोण आहे? माईक अनम्यूट करू नको, म्यूट कर, कारण तुझ्या घरातला बोललेला आवाज सगळा ऐकतो. फॉर्मेशन ऑफ इथर्स. आवाज क्लिअर येतोय की नाही?
सर ब्रेक होतोय सर.
आता
येतोय सर. येतोय
आवाज. Formation of ether. Ethers are organic compound containing carbon, oxygen, carbon linkage. And in this reaction, halo group is replaced by OR group. Halo group is a negatively charged, and here OR group is also negatively charged. One nucleophile is replaced by another nucleophile. In a general reaction, when alkyl halides RH, a general formula for alkyl halide, when treated with general reaction NaOR, from this NaOR, this sodium is positively charged, OR group is a negatively charged. This reagent is commonly known as a sodium alkoxides. Sodium alkoxides. In this reaction, this halo group and this sodium atom forms sodium halide. Sodium and halo group form sodium halide, and this OR group get attached to this R group to form ROR along with NaX. ROR is general formula for ether. For example, number 1, when CS3Cr is treated with NaOCH3. From this NaOCH3, sodium positively charged, remaining group OCH3 group is a negatively charged. In this reaction, here chlorine is a negatively charged, therefore this chlorine combines with sodium and this OCH3 group to this CH3 group, CH3OCH3. In this compound, carbon, oxygen, carbon linkage is present. Therefore, this compound is an example of ether. Name of this ether. Here two like groups are present, therefore di. CH3 groups are called methyl group and followed by word ether. Plus NaCl. Plus NaCl. One more example. Here, negatively charged chlorine is replaced by negatively charged OCH3 group. Therefore, nucleophilic substitution reaction. That is, one nucleophile is replaced by another nucleophile. One more example. CH3CH2Br. Name of this reagent. आता इथे जो reagent use केला ना त्याचा name पहा. Here sodium is present, therefore sodium. And here methyl group is attached to oxygen, therefore methoxide. Sodium methoxide. Here CH3CH2Br is treated with NaOCH2 and CH3. Name of this reagent. Here sodium is present, therefore sodium. OCH3 group is present. The C2H5 group is attached to oxygen. C2H5 group, that is the ethoxy group. Ethoxide. Sodium ethoxide. The bromine and this sodium form sodium bromide. And this OCH2CH3 group get attached to this carbon atom to form CH3, CH2, oxygen, CH2 and CH3. Name of this ether is a di. Di means two. Two light groups are present across oxygen atom. CH3 CH2 group is known as a ethyl group. Two ethyl groups are present, therefore diethyl, and followed by one ether. In this way, when alkyl halides are treated with sodium alkoxide, then final products are ether. And this reaction is an example of nucleophilic substitution reaction. Why? Here halo group is replaced by OR group. Halo group is negatively charged, OR group is also negatively charged. Therefore, reaction is a nucleophilic substitution reaction. Is the second reaction. समझ गए?
हो सर.
Yes, sir.
Okay. Third substitution reaction. Third substitution reaction, that is a formation of ester. Formation of esters. एक मिनट जरा मैं इंक ऐड कर रहा हूं. And what are esters? Esters are organic compound containing C double bond OR group as a functional group. And here this carbon atom is attached to R group, alkyl group. Therefore, this is general formula for ester. Formation of ester. In this formation of ester, when alkyl halides, this is general formula for alkyl halide. When alkyl halides are treated with silver salt of carboxylic acid, AgO, C double bond O R. This is general formula for silver salt of carboxylic acid. Silver salt of carboxylic acid. And when alkyl halides are treated with silver salt of carboxylic acid, from the silver salt of carboxylic acid, silver group is positively charged and the remaining group is negatively charged. Where halo group is negatively charged, R group is positively charged. Where one negatively charged group, that is a nucleophile, is replaced by another negatively charged group, that is a nucleophile. Halo group and silver atom form silver halide. And this remaining group get attached to R group to form R O C double bond O R plus AgX. हा जो फॉर्म्युला आहे ना तोच इथे मिळाला आहे. तिथे या डायरेक्शनने लिहिला आपण, या डायरेक्शनने लिहिला वन एंड दिस साइड. And this is general formula for ester. For example, when CH3 Br is treated with AgO C double bond O CH3, that is a silver acetate. This salt is obtained from acetic acid, therefore acetate. If silver is present, therefore silver acetate. This halo group and silver form silver bromide, and this remaining group get attached to the CH3 group. Therefore, CH3O C double bond O CH3 plus AgBr. Name of this salt. आता या सॉल्टचं नेम आपल्याला तयार करायचं आहे. तर CH3 group is attached to oxygen. CH3 group is known as a methyl group and acetate. Name of this salt is a methyl acetate, and this methyl acetate is an example of ester. There is C double bond O CH3 group, that is the ester functional group is present. In this way, alkyl halides are converted to esters when treated with silver salt of carboxylic acid. Alkyl halide आणि silver salt of carboxylic acid ची रिएक्शन कंप्लीट केली की esters तयार होतात. ही झाली आपली थर्ड सबस्टिट्यूशन रिएक्शन. फोर्थ सबस्टिट्यूशन रिएक्शन, there is a Formation of amines. Amines are organic compound containing NH2 functional group. In this reaction, when alkyl halides Rx treated with ammonia, formula for ammonia NH3. Formula for ammonia NH3 is ammonia. Or this formula can be written like this H and NH2 in presence of alcohol, alcoholic solution, alcoholic ammonia. Ammonia का formula इथे दिला आहे. Halo group and hydrogen atom from ammonia forms hydrogen halide and NH2 group get attached to R group, RNH2 plus HX. And this is general formula for amines. Amines are formula. For example, CH3, CH2I is treated with ammonia, NH3 in presence of alcohol, iodine and hydrogen forms hydrogen iodide, and NH2 group get attached to the CH3 CH2 group. CH3, CH2, and H2 plus AgI. Sorry, HR, hydrogen iodide. रिएक्शन अगदी सिंपल आहे का हॅलो ग्रुप काढून टाकायचा आणि फक्त NH2 ग्रुप जॉईन करायचा. दिस इज द बेस फॉर दिस रिएक्शन. कोणती ऑर्गॅनिक रिएक्शन असते की त्याला बेस असतो, तो बेस लक्षात ठेवायचा. या रिएक्शन साठी बेस काय? हॅलो ग्रुप काढून टाकायचा आणि NH2 ग्रुप फक्त जॉईन करायचा. तर फायनल प्रॉडक्ट्स आर अमाइन. आता इथे बोर्डवरती एक्सप्लेन करताना मी एक किंवा दोन एक्झाम्पल एक्सप्लेन करत असतो. पण तुम्ही लेक्चर संपल्यानंतर मॅक्झिमम जास्तीत जास्त एक्झाम्पलचा ट्राय करायचा. रिएक्शन समझले का? फॉर्मेशन ऑफ अमाइन्स.
Yes, sir.
The next reaction, fifth substitution reaction. Fifth substitution reaction, formation of cyanides. And what are cyanides? Organic compound containing CN functional group. CN functional group are called cyanides. And in this reaction, again, in this reaction, halo group, negatively charged group, is replaced by CN negatively charged group. There is one nucleophile is replaced by another nucleophile. For example, of nucleophilic substitution reaction. The general reaction आपल्याला explain करायची. When alkyl halides are treated with potassium cyanide, KCl, potassium cyanide, in presence of alcohol. And halo group and potassium forms potassium halide. And then CN group get attached to R group to form RCN plus KX. And RCN is general formula for alkyl cyanide. For example, when CH3, CH2, Cl is treated with KCl in presence of alcohol, chlorine and potassium forms potassium chloride. And Cl group to this carbon, it gives CH3, CH2, Cl plus KCl. CH3, CH2 group is an ethyl group. And Cl group is present, therefore cyanide. In this way, alkyl halides are converted to alkyl cyanide. What is the base for the reaction? Reaction चा base काय आहे? हॅलो ग्रुप जो आहे तो काढून टाकायचा आणि Cl ग्रुप जॉइन करायचा. Next, substitution reaction, formation of isocyanides. Isocyanides, that is a compound containing NC functional group. Compound containing CN functional group are called cyanides. And when organic compound contains NC functional group, then compounds are called isocyanides. Formation of isocyanides. When alkyl halides are treated with silver cyanide, AgCl, silver cyanide in presence of alcohol. Halogen and silver form silver halide. But here in this reaction, their bond is formed between nitrogen and alkyl group. Their bond is formed between carbon and alkyl group. Plus AgX. For example, CH3, CH2, Cl when treated with AgCl in presence of alcohol, and it gives CH3, CH2, and C plus AgCl. CH3, CH2 group is a ethyl group, and NC group therefore isocyanide, ethyl isocyanide. आता हा फक्त आपण काय केलंय रिएजंट चेंज केला इथे यूज केला पोटॅशियम सायनाइड इथे यूज केला सिल्वर सायनाइड आता तुमच्यासाठी एक क्वेश्चन when alkyl halides are treated with potassium cyanide then final products are cyanides but when alkyl halides are treated with silver cyanide then final products are isocyanide what is the reason याचा रिझन काय ते तुम्ही हा लेक्चर संपल्यानंतर शोधून काढायचं आणि तो तुम्हाला जर शक्य झालं व्हॉट्सअप ग्रुपला आपल्या पाठवून द्या मला त्याचा आन्सर क्वेश्चन समजला का इथे सायनाइड तयार होतात दॅट इज बॉन्ड इज फॉर्म बिटवीन आर ग्रुप अँड carbon atom from Cl group. And in this second reaction, their bond is formed between R group and nitrogen atom from Cl group. इथे R group आणि कार्बन बरोबर बॉन्ड तयार होत नाही याचं रिझन काय ते तुम्ही मला सांगायचं हा समजलं का दोन रिएक्शन फॉर्मेशन ऑफ सायनाइड अँड फॉर्मेशन ऑफ आयसोसायनाइड हॅलो
Yes, sir.
ओके याचं रिझन फक्त मला सांगायचं नेक्स्ट केमिकल प्रॉपर्टी formation of alkyl nitrite. Formation of alkyl nitrite. When alkyl halides are treated with potassium nitrite, KNO2. Name of this reagent, here K that is a potassium is present. Potassium and NO2 group that is a nitrite. Potassium nitrite. Formula for potassium nitrite can be written like to this: K plus O N double bond O. Therefore, this oxygen atom is negatively charged. When alkyl halide and potassium nitrite react together, and this halo group and potassium forms potassium halide. A new bond is formed between R and O group to form RONO plus KX. And such type of compounds are called alkyl nitrite. Alkyl nitrite. For example, when CH3 CH2 Cl is treated with potassium nitrite KNO2. This formula can be written like this: KON double bond O. That is a KNO2. Potassium and chlorine forms potassium chloride. To form CH3 CH2O N double bond O plus KCl. And name of this compound CH3 CH2 group is ethyl group. And this ONO group, that is the NO2 group is present, therefore nitrite. And last reaction, it is a formation of alkyl nitrate. Formation of nitroalkane. When alkyl halides are treated with silver nitride, AgNO2. Silver nitride. Silver positively charged, this group negatively charged. Then halo group and silver atom form silver halide. And NO2 group, this R group. It gives RNO2 plus AgX. For example, when CH3CH2Cl is treated with AgON double bond O, then silver and chlorine form silver chloride. And here bond is formed between carbon and this nitrogen atom to form CH3CH2 nitrogen double bond O oxygen negatively charged plus AgCl. इथे आपण रिएक्शन कंप्लीट केली की काय तयार होतं अल्काइल नायट्राइड तयार होतं and that is a bond is formed between carbon atom and oxygen atom. And when silver nitride is treated with alkyl halide, then here bond is formed between carbon and nitrogen. Final products are nitroalkanes. Name of this nitroalkane is a nitroethane. इथे परत तुम्ही रिझन शोधायचं. Why here bond is formed between carbon and oxygen atom, and here bond is formed between carbon and nitrogen atom. Nucleophilic substitution reaction. किती रिएक्शन एक्सप्लेन केला आपण टोटल 8 रिएक्शन 8 रिएक्शन एक्सप्लेन केला. यामध्ये कोणाची काय डिफिकल्टी? हॅलो
नो सर.
ओके ठीक आहे. घरी म्हणजे लेक्चर्स नंतर परत प्रॅक्टिस करा. परत मगाशी सांगितलं तसं मी युट्यूब एक चॅनल मी तयार केलेलं आहे, त्याची लिंक तुम्हाला मी नंतर पाठवतो. त्यावरती हे सगळे व्हिडिओ तुम्हाला परत ऑब्झर्व करता येतील, पाहता येतील. ओके बाय. उद्या 6:15 आपलं लेक्चर होईल.